Let's see the next topic from computer awareness. It is computer memory. Student, in this particular chapter, you will find these types of question. The first one and the very important one is related to memory units. Basically, their conversion also. Like 1 GB is equal to how many KB? Such type of question can be asked from this particular subtopic. The next one is the classification of memory. Okay, so he can ask you the type of memory from the options. Okay, the next one is on the specific memory. Okay, so he will take any type of memory and from that particular memory he can ask you the question. And the last one is the memory hierarchy, where he can ask you the speed and size of a particular memory. Okay, like which of the memory is fastest or which of the memory is the slowest one. Okay, so let's see what are the memory units. So first thing you should remember, all the memory units are in the power of 2. This 2 is very powerful in the computers. We will see in the later class. For the timing, you just remember all the memory units are of power of 2. And since there are two options, either 0 and 1, so it will have 2 power and distinct value. Okay. So the very first one is the bit. So in exam, he can ask you the full form. Okay, what is the full form or abbreviation of bit? Remember, it is binary digit. So from binary it is BI, and from the digit, the last one T. So binary digit, the full form of bit is binary digit. And as you know, the word binary means 2. So basically this binary means 2 radix. Okay, radix is there that we are going to see in data representation. Okay, so the binary means 2 radix. 2 radix means it is able to identify 2 symbols. What are those symbols? 0 or 1. Okay, so the 1 bit means binary digit, and this 1 bit, as we have seen, there are 2 and distinct value. So 1 bit means 2 power 1, that is 2. So 2 distinct value can be identified, 0 or 1. The next is the nibble. So if you combine 4 bits, it will become 1 nibble. So in exam generally ask is the what is called the collection of 4 bit, it is nibble. Okay, the next one is byte. So when you combine 8 bits, it become bytes. Okay, so when you combine 8 bits, it become byte. And or in other words, if you combine 2 nibbles, you will have 1 byte or 8 bits. Okay, so let me repeat once again. 1 bit is binary digit, 4 bits is equal to 1 nibble, and 8 bits equal to 1 byte or 2 nibbles. The next one is 1024 bytes. So that's what I am telling you, it is power. 2 power 10 is what? 1024. Okay, so when you combine 2 power 10 bytes, it become kilobyte. Okay, KB means kilobyte. Okay, so 1 kilobyte equal to how many bytes? 1024 bytes. But if I ask you 1 kilobyte has how many bits? So again, as you know, 1 byte is 8 bit. So your answer would be 1024 into 8 bits. So okay, I will write 1024 into 8 bits will be there in 1 KB. Okay, let's see the next. 1024 KB. Okay, so again, if you have 2 power 10 KB, it will become 1 MB. Okay, 1 megabyte. So 1 megabyte equal to 1024 KB. Okay, similarly 1 GB is equal to 1024 MB, and 1 TB is equal to 1024 GB. Okay. Afterwards we have PB, that is petabyte, exabyte, zettabyte, yottabytes, brontobyte and geobyte. Okay, so you can ignore these two, these are not asked in exam, but till yottabyte you should remember. Okay, yottabytes, there is one trick you can remember from this trick, kmgt pesi. Okay, kilo, mega, giga, आगे टेरा, पेटा, एक्सा, zeta and yotta. Okay, kmgt pesi, kilo, mega, giga, tera, peta, exa, zota, yotta. Okay, kmgt pesi. Okay, and in exam what he can ask you, the calculations. Okay, like how many TB makes 1 PB, petabyte, or in other word, like 1 MB is equal to how many bytes, or 1 TB is equal to how many MBs. Okay, such type of question can be asked in an exam, and we are going to see one session on those particular conversion. Okay, so let's see, the next important topic is the classification of memory. So in classification of memory, you should remember this hierarchy. Okay, so basically there are two types of memory, primary memory and secondary memory. And in primary memory there are two types of memory, random access memory and read-only memory. Don't worry, we are going to see detail in the upcoming sessions. And just remember, there are 4 types of RAM: SRAM, static RAM, dynamic RAM, synchronous dynamic RAM and double data rate RAM. Okay, similarly, read only memory, there are 3 types: PROM, EPROM, EEPROM. Coming to the secondary storage, magnetic storage, optical storage and solid state storage. And in magnetic storage we have 3 types. In optical storage, again commonly these are the 3 types: CD, DVD and Blu-ray. Whereas in solid state, these are commonly secondary memory used in the computers. Apart from these, there are certain other memory like CPU registers, cache and virtual memory that we are going to discuss in the upcoming slides. Okay. So student, remember, memory is the storage space where data and instructions are stored temporarily or permanently. Okay, it is basically like a box which stores the data and instructions either temporarily or permanently. And just remember, all the electronic components which are residing inside the computer are made up of semiconductor, mainly silicon. Okay, this type of question we have seen in RRB JE. Okay, so all the electronic components are made up of semiconductor material, silicon. Coming to the next one is the categories. So we have seen that it can store data temporarily or permanently, based on which there are 2 categories specifically: primary memory, or which is also called the main memory. Afterward, the second one is the secondary memory or auxiliary memory. Okay, so these are the 2 types of memory which are commonly asked in the exam. So coming to the primary memory or the main memory, the first thing you should remember why it is called the primary memory or the main memory. Why it is called the main memory? Because it is the first memory that CPU access directly to perform any task. Okay, so whenever he wants some information or data, it is the first memory he will be going to look. Okay, so CPU will access directly the primary memory first. Afterward, it is going to access the secondary memory. Okay, so based on which there are 2 types of primary memory: ROM and RAM. Okay, RAM and ROM. So just remember, ROM as a word itself says read only memory. Read only means it is be used only for reading, okay, not for the writing. And since it is read only memory, so it will be non-volatile. Generally in exam you will have these type of question where he is going to ask you related to volatile and non-volatile. And remember, ROM, read only memory, is non-volatile. Non-volatile means what? That data remains in the device even after the power off. That's why it is read only memory, right? So since data will not be going to erased after power is off, once power is off, data remain off, it is volatile. Okay, volatile as a word also knows that it will not remain in the memory. But in the non-volatile, data remain even after the electricity is off. Okay, so that's why read-only memory are used to store the firmware, basically the BIOS, which have booting instruction in it. Okay, and these are the classes of the ROM: PROM, EPROM, EEPROM. Okay, so in exam he can ask you the non-volatile or volatile related question from this particular chapter. Coming to the RAM, as the word suggests, random access memory, and it is a volatile memory. Why it is called volatile? Because data is lost when power is off. So if you turn off the PC, data will be lost, whatever the inside in the RAM. Okay, and it is basically used to store the data temporary. Okay, whereas ROM is used to store the data permanently, and RAM is used to during the execution of the program. And there are 4 type of RAMs: SRAM, DRAM, SDRAM and DDRM. Okay, coming to the type of RAM, the first RAM is the SRAM. The full form you should remember. RAM we already seen, it is random access memory, and the word S stand for the static. Okay, why it is called static? Because there is no refresh needed. What do you mean by refresh? There are no component in it for which refreshing is required. Okay, so if we see the dynamic RAM, you can appreciate it much better. The dynamic RAM basically uses the capacitor. So in exam, if we ask which of the memory uses the capacitor, your answer should be dynamic RAM, DRAM. And since, as you know, capacitor are the elements or the electronic circuits which store the data in the form of charges, so over the period of time this capacitor may dissipate, and because of which periodic refreshing may be required. Okay, so this DRAM basically use the capacitor and need periodic refreshing to get the memory. Okay, the next one is SDRAM. It is similar to dynamic RAM, so capacitor will be there, but one more thing has come into SDRAM. They are synchronous. How synchronous? It is synchronous with the CPU. So what is the advantage of having synchronous with the CPU? So if I am synced with the CPU, I can have wait time for reading and writing operation will be reduced. Okay, so in this way it is faster than DRAM. Okay, so SDRAM is faster than DRAM because it is sync with the CPU. Okay, the next one, nowadays everybody is talking about DDRM, that is double data RAM, and it is similar to SDRAM, but the thing is that per clock cycle it transfers the data twice, so the rate of transfer is doubled, so it is called DDR, double data rate RAM. Okay, and nowadays DDR5 are used in the modern system. Okay, let's see, the next is ROM. So as you can see in the figure, so this chip is basically a ROM, that is read only memory, and as the word suggests, PROM means programmable ROM. Once it is programmed, it cannot be writing again. Okay, whereas if you have EEPROM, that is erasable programmable ROM. It is can be used from programming, but it can be erased with the help of UV light. So in exam, if we ask which of the ROM is used to erase with the UV light, your answer should be EEPROM, erasable PROM. Okay, and sometimes this EEPROM is also known as UV PROM. Okay, so EEPROM can be erased, but PROM is not erasable. Whereas one more type is there, it is EEPROM. Instead of UV light, you are using the electricity for erasing the programmable ROM. So it is called EEPROM. So from ROM, you should remember the full form of each and every type of ROM. Let's see, the next one is the secondary memory. So as you have seen in the primary memory, they are used to store the data for the shorter period of time for the data which is going to be used during the program execution. But if you want to store the large amount of data like OS files, software and documents, secondary memory is required. Okay, and the first important point, it is not directly accessed by CPU. Suppose your CPU want to access your OS or files, software which are in the secondary memory, it must be transferred into the primary memory. Okay, so that is a concept of stored principle that we have seen in the early classes. Okay, and one of the important characteristic of secondary memory, they are non-volatile. We have seen this terminology many times. Non-volatile means the data will remain in the storage device even if electricity is gone, even if power is off. Okay, so that's why if you have a pen drive, the data remains there even if it is not connected to the PC or electricity. Okay, and secondary memory generally stores the large amount of data and very cheaper than RAM. These are the common things that everybody knows. And the examples you should remember, there are four examples of secondary memory: magnetic storage, optical storage, solid state storage and cloud storage. Okay, and we are going to see in the upcoming slides about each and every storage. So in the magnetic storage, first thing you should remember that it uses the magnetism to read and write the data. Okay, so with the help of magnetism property, it is going to read and write data onto the chip. Okay, and generally these storage devices are very cheap and it can store large amount of data. And example are magnetic tapes. So these are the tapes. So as you can see, ribbon is there. So ribbon has the magnetic characteristic over that. Okay, then we have HDD, that is hard disk drive. So this is the hard disk drive. So as you can see, there's spindle, platters, read write head arm. I'm not going to discuss about the internal of HDD, but remember it is a magnetic storage device. And a very older one is a floppy disk. Nowadays it is obsolete, but it looked like this. And the most common one is the 3.5 inch floppy, which is used by the most of the people. Okay, so floppy disk is again a magnetic storage device. Coming to the next one is solid state storage device. Instead of magnetism, these type of storage device use NAND flash electronics. Okay, NAND is one circuit in the electronics which is used to read and write the data. Okay, so if you see HDD and SSD, it become very small in size, and NAND flash memory are also there, controllers and cache are also there. Okay, so the size got reduced and it cost also got reduced. Okay, so it become fast, compact and durable. And the examples you should know, it is SSD, the alternative of HDD. And whereas pen drives are also known as USB flash drive, and the thumb drives are also solid state storage device. In other words, they are also secondary storage. And the next one is the memory card. SD card, which are generally used in mobile phones right now. Okay. The next one is a optical storage device. You have heard the terminology like CD, DVD and Blu-ray disc. The full form you should remember: CD means compact disc, DVD means digital versatile disc, and Blu-ray disc. Okay, why it is called Blu-ray, that we are going to discuss just now. Okay. So first thing you should remember that optical storage device, as the word suggests, it is going to use some sort of optics. Optics means it is going to use some sort of light. So instead of magnetism or NAND electronics, it is going to use laser light to read or write the data. Okay, so how it is going to read or write data on the laser light? Because this CD has certain surface which is made up of polycarbonate refractive surface. This is for your information only, and it stores the data in form of some pits and lands. Okay, some pits and lands are there inside the CD or DVD, with the help of which it is able to identify whether it is 0 or 1. In other words, it is going to store the data in this particular device. And in exam, in SSC CGL, we have seen they have asked the laser light wavelength used in CD. So remember, the laser light wavelength used in CD is 780 nm, whereas in DVD it is 650, and in Blu-ray it is 505 nanometer. Okay, so CD around 700, DVD around 600, and Blu-ray around 400. So what is the advantage of having this wavelength? You can also think like the smaller the wavelength will be, narrow will be beam, and it is able to detect those pit, and therefore more data can be stored. Okay, so Blu-ray disc stores GBs of data, whereas CD generally used for storing the data up to 700 MB. DVD is generally used to store the data up to 4 GB. Okay, so for this particular topic, you should remember laser light is used to read and write data, whereas the wavelength used in the laser for CD is 700 nanometer. For Blu-ray it is 400 nanometer. And these are the 3 examples. Let's see the next memory, that is cache memory. And this is very important topic, and generally in exam it is asked from this cache memory. It is basically the memory which sits between RAM and CPU. Okay, so your CPU is there, RAM is there, so near to CPU one cache is there, so it sits between RAM and CPU. The next one, where it is located inside CPU or near the CPU. Coming to the next, this one in the last year we have seen in the CGL, a very difficult one. On what principle this cache memory is used? It is based on the locality of reference. Means the nearer the data, the nearer will be the reference. Okay, the faster it will be. Okay, so the locality of the reference principle is used in the cache memory. And obviously it is a volatile because it depends upon the electricity to operate. And the next one, it is more faster since it is closer to CPU, more the faster, and it will be smaller in size. It is not like secondary storage device or the RAM. It is generally smaller in size, of having size 256 to 2 MB. Since it is very smaller in size, it is expensive. Coming to the last topic of this particular session is the memory hierarchy. And as you can see, the more closer to the CPU is registers. Okay, but before register, one important electronic circuit is flip-flop. What is flip-flop? Flip-flop is again an electronic circuits which is used to store 1 bit of data. Okay, and in exam we have seen this question, like he will ask which of the following electronic circuit is used to store 1 bit of data. Your answer would be flip-flop. Okay, flip-flop is used to store 1 bit of data. Coming to the next one is the register. So as the diagram says, the more you go closer to CPU, faster you should be, and the size it will be increased. Okay, so the hierarchy is registers, after that cache memory, then you have main memory, secondary memory. Okay, so if you ask like which of the following memory is the fastest, your answer should be registers. Okay, so out of these thing, okay, registers are the fastest one. Why? Because they are closer to CPU. Okay, afterwards it is the cache memory, afterwards primary or main memory, and finally the secondary memory. Okay, so this is a memory hierarchy. Remember, the fastest one is the register, then cache memory, then primary, then secondary. It is not the cache memory, it is the registers. Again I am repeating, registers are the fastest memory, whereas the slowest one are the secondary memory. Okay.